Squares and roots are what we're going to look at. So squares you should be familiar with to some degree. Squares are working with the power of 2 on numbers. So when you square a number, you're just multiplying it by itself. So if we're looking at the concept of 3 squared, that just means 3 times 3, or 3 to the power of 2. So when we say squared, generally we're referring to the exponent up here being the number 2. So it's up, or something raised to the power of 2. So 3 times itself, and we get 9. Now note, this is where a lot of people make a mistake, especially with squares for some reason, that when we say 3 to the power of 2, 3 squared, some people think that it's 3 times 2. That is not 3 times 2, it is 3 times 3. That superscript number 2 there, that is telling us how many times we're multiplying 3 by itself. So whenever 3 squared is 9, so when we talk about squares, you can actually think about the square itself. So that's where the term comes from. It's actually working with the area of a square. The area of a 3 by 3 square is calculated by taking 3 squared, the length times the length, 3 times 3, and that equals 9. So the area of a square, that is 3 by 3, is 9, and that idea of 3 squared being 9, when we square the 3, it becomes 9. So it's actually a physical representation. Now you should be familiar with some of the perfect squares. These are just ones that, some squares that have no we don't work with any decimals, we're just multiplying an integer value by itself. So 1, 2, 3, 4, and so on. Any integer value would make a perfect square, so 100 times 100, 963 times 963. When you multiply those, they make a perfect square. Ones you should be familiar with, though, are from our multiplication chart. 1 squared through 12 squared. So when we calculate those, your 1 squared is 1, so 1 times 1, 2 times 2 is 4, 3 times 3 is 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. So these ones here are very important. We'll use them a lot, and they become very useful if you can start trying to memorize those and become familiar with them. So when you see 49, you recognize right away that it is 7 squared. Things like that will really help. A couple other ones that can be useful along the way and are somewhat easy to remember. 169 is 13 squared, and then 196 is 14 squared. It's nice those numbers just flip, and that's how I remember them. 15 is 225. 20 squared is 400. Notice, 20 squared, 2 times 2 is 4. 20 times 20 is the 2, and that gives you this 4 there. And then we have these 2 zeros here. 25 squared is 625. And this one's just, this set of numbers comes up often when we're working with things like quarters and fractions like that as well. So that's our squares. We'll switch this over to the roots and take a look at those in a second. So now when we look at roots, we're going to be using this symbol here called the radical sign. And that radical sign is used to ask the question of, in this case, what number times itself is whatever. So this is a square root in our case here. And so if we have the example down here, we have a square root of 9. What is the square root of 9? What number times itself is 9? Well, 3 times 3 is 9. So 3 times itself is 9. Thus, the square root of 9 is 3. Now, technically, we should be using this little 2 in here. So we should be putting a 2 in here technically to show that it's a square root. But if it's not there, we assume it's a 2. However, there are cubed roots, which would ask what number times itself 3 times is that number. But we won't get into those this year. But be familiar with that. So square, opposite of a square is a square root, and it's just asking us what number squared is 9, or whatever number we're working with. So something that you should know again, same as the inverse of our perfect square chart. We have our square roots of these perfect squares. So when we have them there, 144, inverse of that is 12. So the square root of 144 is 12, square root of 121 is 11, square root of 100 is 10, square root of 81 is 9, square root of 64 is 8, square root of 49 is 7, square root of 36 is 6, square root of 25 is 5, 16 is 4, square root of 9 is 3, square root of 4 is 2, and the square root of 1 is 1. So again, knowing our perfect squares and the numbers that square to them, so the squares of 1 through 12, that will help us easily do these. We'll be using these a lot within our calculations, especially when we're doing some work with area and perimeter, and then when we get into the section with Pythagorean's theorem. So try and be familiar with those.